So look at question number 7 on worksheet number 3 now. Really hard question, I thought at least. Really challenging question. It says a person holds a 15-kilogram gun containing a 50-gram bullet riding on a train that's traveling at 75 kilometers per hour to the east. Right away, we got some red circle stuff here, kilograms, grams, kilometers per hour. Man fires the gun, and the bullet moves at a velocity of 350 meters per second east relative to the train. What's the velocity of the gun relative to the ground? What makes this tricky is that we have 2 frames of reference here, and we need 1 frame of reference. We always need 1 frame of reference for a question like this. It's either the train or the ground. So do everything relative to the train or do everything relative to the ground. And at the end, you may have to convert back from your frame of reference, but through the question, you can't have part of your data relative to the train and then part of it relative to the ground. So what I chose to do when I did this question, I don't know about you, does work both ways. I chose to do it relative to the train. You could do it relative to the ground, but relative to the train made it easier to do the conservation of momentum because relative to the train, nothing was moving before the interaction took place, right? The gun and the bullet were on the train, moving with the train. So if you're sitting in a train seat and you're looking at that gun next to you, by the way, I wouldn't recommend taking a gun on a train, or especially firing it. But if you're looking at that gun next to you, it appears to be not moving, right? Because relative to the train, it isn't moving. Now, somebody standing on the ground looking through the window would see it moving, but that's another frame of reference. So we're going to say relative to the train, although it does work the other way as well. We're going to say that M1, that's going to be the mass of the gun, 15 kilograms. I'm going to say M2, that's the mass of the bullet. I'm going to make it 0.050 kilograms. Got to be in the same units, right? I'm going to say relative to the train, VI is what? The gun and the bullet are both not moving relative to the train. VI is 0. And that's why I chose that, because it does make the math easier there. Now I'm going to say V2F, that's the velocity of the bullet immediately after it's fired. V2F is, man fires the gun, bullet moves at 350 relative to the train. This is good, right? That's what I want, relative to the train. 350 meters per second. I'm looking for V1F, but I'm going to put a little asterisk beside that because what I'm going to solve for here is V1F relative to the train, and what I want is V1F relative to the ground. So don't worry about that. Get it relative to the train and then convert it to relative to the ground after the fact. So I'm going to say PI is equal to PF. I'm going to say 0 initial momentum equals M1 V1F plus M2 V2F. Like mathematically, this question is not very hard. It's just conceptually, it's pretty challenging because of those 2 frames of reference. 0 is equal to 15 times V1F plus 0.050 times V2F, which is 350. Now we're going to solve for V1F here. Gives me a negative 1.16667 meters per second. Is that my final answer? No, this is the velocity of the gun relative to the train. And that number should make sense, right? Bullet goes forward at 350, gun goes backward, but a lot slower, right? How come the gun goes backward a lot slower? Kenzie, how come the gun goes backward slower than the bullet goes forward? Well, the gun's pushing the bullet, bullet's pushing the gun, equal and opposite forces, but the gun goes backwards a lot slower because it's a lot heavier, right? All right, so how do I get the velocity of this thing now relative to the ground, which is what I'm looking for? If you remember in Physics 20, relative motion always involved adding vectors. Now, the good news is the vectors that you add here, the addition is easy. It's just a matter of knowing what to do. If I was on a moving walkway, you know those moving walkways at airports, right? For the life of me, I still can't figure out why they have them. Because you got to walk from security to like your gate, which is like, seems like a kilometer sometimes. And then for like 30 meters, they have this moving walkway to save you. Like, but they make you walk the other 970 meters without the moving walkway. But whatever. Everybody always takes them, right? Like when you come to those moving walkways, do you not get on it? I sometimes like to get on the other one, actually, the one that's moving the other direction, as long as there's nobody on it, and then just run and beat it the other way. Like the escalators, like to run up the down escalator. Listen, if the moving walkway is moving to the east at 3 meters per second, and you are walking to the east at 3 meters per second on the walkway, like you can walk at 3. Got it? So it's moving at 3, and you have the ability to walk at 3. So you get on the walkway, and you walk with it to the east at 3. How fast are you moving relative to that convenience store over there that's beside the moving walkway? That's the thing that gets me too. Those moving walkways, it always seems to be like you get on it, and then the store that you want to go to is like right in the middle. So then you have to get on it and then get off and walk halfway back, which means you probably should have just walked up the first time, but it was less fun doing that. So you see that convenience store that's beside the moving walkway. Somebody's standing there watching you. How fast are you moving relative to them? 6. How'd you figure that out, Aiden? Yeah, 3 plus 3 is 6, right? The walkway was moving at 3 to the east. You're moving at 3 to the east relative to the walkway. Add them up gives you 6, right? Okay, what if you're just looking to have a little bit of fun and the walkway is moving to the east at 3 and you're moving to the west at 3. So you're capable of walking on the walk, moving at 3 meters per second, but you get on the walkway moving in the opposite direction or walking in the opposite direction. If it's going 3 to the east and you're walking 3 to the west relative to the walkway, the guy standing there in the convenience store, he sees you doing what? How fast are you moving relative to him? 0, right? How'd you figure that out? Yes, I was waiting for somebody to say subtract. You do not subtract. When you're doing relative motion, it's always add. 3 plus negative 3 is 0. So when you're analyzing relative motion, you add vectors together. Now listen, if I want to find the velocity of this gun relative to the ground, the velocity of the train, look, the train is 75 kilometers per hour. That's going to be 20.8333 meters per second. Pretend this is the walkway. The walkway is moving at 20.833 meters per second, but the gun is moving the other way. It's like me going the opposite way on the moving walkway, right? So I have to add the negative value. The negative 1.1667 gives me a value of 19.7 meters per second. Now, it is conceivable, just because of the numbers involved here, to get 19.7 but not do it correctly. So just watch to make sure that you've done the question correctly. Okay? If you've done it this way, good, you've done it correctly. If you've done it relative to the ground right away, you've done it correctly. But everything would have to be relative to the ground. If that was the case, you would say VI, the gun and the bullet, would be 20.833 relative to the ground. V2F wouldn't be 350 because that was relative to the train. Okay, it would be, what would it be? 370.833? Make sense? Because that would be like moving at 20 meters per second on the moving walkway when the moving walkway was moving at 350. So if you were consistent through the problem, you would have gotten the right answer. By the way, if you had done it that way, you wouldn't have had to convert at the end, right? You would have gotten a V1F that was 19.7 meters per second without doing that extra step at the end. Yeah, how many people got that? Okay, I saw a couple hands kind of like didn't want to admit it because nobody else got it, but good for you if you got it. That's a hard question. Okay. Honestly, I'd be surprised if you saw a question that was like that on an exam. You never know, but I'd be surprised. I think two different frames of reference makes it a little bit harder than what we're likely to see.